Okay, so here we have another differential equation that we're going to be working on, and this is a second order linear non-homogeneous differential equation. And the the general solution, of course, is going to be of the form yc plus yp, where yc is the complementary solution and yp here is the particular solution. So the full solution is going to be the sum of these two solutions. And in order to solve for yc, where yc is the homogeneous solution, we have to solve this homogeneous differential equation here, which is the same as this, except we have a zero here instead of f of t. So the first thing we're going to do is to find the solution to the homogeneous equation, right, our complementary solution. And once we have the solution, if no term in f of t repeats in our homogeneous solution, then we are to guess a linear combination of f of t and all of its linearly independent derivatives. Okay, so of course this is assuming that f of t has a finite number of linearly independent derivatives. Okay, so we've gone ahead here and I've gone ahead here and solved for the complementary solution right away, so that we don't have to waste time writing that down. So our solution is a times cosine 4t plus b times sine 4t. So that's the solution to the homogeneous equation. Now, we notice here that no term in the complementary solution repeats in f of t, just like part 2 says, right? We have to make sure that no term in f of t repeats in the complementary solution. Now, since that's the case here, that means we can now guess a linear combination of f of t and all of its linearly independent derivatives. Okay? And that means that our guess is going to be of the form a times t plus b multiplied by e to the power of 2t. So this is our guess for our particular solution. So our first derivative for yp prime is going to be a e to the power 2t plus at plus b times 2 e to the power 2t. And for our second derivative, we're going to have 2 times a e to the power 2t plus, let's see, 2a e to the power 2t. Let's see, and then we are going to have a 4 times at plus b e to the power 2t. Now we can of course combine this to give us a 4a 4a e to the power 2t. So let's go ahead and plug these values into the differential equation. So that means we're going to have 4a e to the power 2t plus 4 times at plus b e to the power 2t. So this is the double prime, and then we have to add 16 times y. So plus 16 times, and y here is going to be our yp. So 16 times at plus b times e to the power 2t, and that's going to be equal to our f of t. So 3t e to the power 2t. So we can go ahead here and combine like terms. So we're going to have 4a e to the 2t times 16b e to the 2t, and then plus another additional 4b e to the 2t. So that means we're going to have 4a and then plus 16b plus 4b. So 16 plus 4 gives us 20. So we're going to have 20b times e to the power 2t. And now we're going to combine the terms involving t. So this is going to be 4at plus 16at. So that should give us a total of 20at. So we're going to have plus 20at e to the power 2t. And let's see if we have everything down here. 4a, 4b, and then 16b gives us 4a plus 20b. And we have 4at plus 16at gives us 20at. And this is going to be equal to 3t times e to the power 2t. And at this point, what we want to do is we want to equate coefficients on both the left hand and the right hand side of the equation. And the way we do that is we take a look at the first term here and we say, well, there's no such term on the right hand side of the equation, so that means this coefficient must be equal to 0. So that means 4a plus 20b must be equal to 0. And then we take a look at this term here, and we know that there's a similar term right here, a t e to the 2t term. So that means 20a must be equal to 3. So we have 20 times a equals 3, which gives a is equal to 3 divided by 20. And since a is 3 over 20, we can plug that in here, and we're going to have 4 times 3 over 20, right here. So that's going to be, let's see, 3 over 5, and then plus 20b is equal to 0, which means b is equal to, let's see here, minus 3 divided by, let's see, 100. Okay, so we have our a and we have our b now, which means we can plug this in here to get the solution, the particular solution, yp. So this means that yp is equal to 3 over 20 times t minus 3 over 100, and all of this times e to the power 2t. And our complementary solution, which we found to be a times cosine 4t plus b times sine 4t. So our full solution to the differential equation then is going to be the sum of these two solutions. So our general solution is y of t is equal to a cosine of 4t plus b sine of 4t, and then plus our particular solution, 3 over 20 times t minus 3 over 100, all multiplied by e to the power of 2t.